All right. Welcome everyone to the Cluster Addons meeting. Today is January the 5th of the new year. So happy new year, everyone. Do we have anyone who's entirely new to the meetings who wants to introduce themselves? Oh, sorry, doorbell. Please carry on.
Takeouts here. Very nice. It's dinner time for Daniel. I think we have all familiar faces here. We still might have quite a few people trickling in since folks are settling back into their routine from the holidays. It's good to see everybody. And yeah, does anyone want to take a chance to add something to the agenda? I know some of us are hacking on fun projects over the break, or getting into some of the open issues that we have currently. Cool. Thanks, Nick. I'll give you a moment to add to the agenda. Yeah. Does anybody have anything in particular that they wanted to just share about their personal life? Well, I mean, I guess this is a recorded meeting too, so. Yeah. I feel very good after the break. Well, I see Nick's adding to the agenda. We had quite a cool 2020, lots of active work. Even just recently, as a refresher for folks, we did get that manifest bundle kept merged in. Justin was moving forward with a lot of work in COPS to align with what we have with add-ons. We have a new contributor who's now also sponsored and working with Weaveworks. And Somtochi, thanks for your work throughout summer of last year. And it's just been great to see all of the collab between large and small companies. So yeah, want to set a good tone for the 2021 cluster add-on stuff. If people are looking at projects that they're taking on, let's go ahead and take some time to talk through things. Yeah. So everyone here mostly knows each other. If you're joining us from YouTube, feel free to try and ping us in our Slack channel, and or make it to this time block. This meeting is totally open for everyone to come with their ideas. I wanted to share something pretty cool that I mentioned last year, that Sunny, the co-maintainer of Ignite, our micro VM manager, has been working on a lot of operator things. And while Sunny hasn't been coming to the cluster add-ons meeting, he's been looking at our code and getting more familiar with kind of the problem set that faces people who are building operators. And we've talked a lot about these kinds of issues. Before, I am not up to date with anything that's been happening inside of Operator SDK to maybe make the programming model more safe. But I think many of us are familiar with just how treacherous like building proper lifecycle and reconciliation inside of a Kubernetes controller can be, since it's, these things are designed to build platforms that take responsibilities, take ownership of responsibilities that are normally watched over very carefully by human beings. So with Operator Toolkit, Sunny's been messing around with kind of adding a little bit more structure. And so I am sharing my screen. I think it's not highlighting it like it usually is. Can you see my browser? Is it doing it?
Yeah, I can.
We can.
Okay, cool. Yes. Thanks. So yeah, in the toolkit package, there is the controller library, I believe, and there are two different patterns. There's the composite and external object sync. And this one's kind of a newer one, but the composite controller just allows you to build things that have child objects. We've seen these patterns in other kind of framework approaches with different design decisions like meta controller and things like that. And composite just has a reconcile that you can wrap, so you can implement a composite reconciler and then take advantage of this method. And so this reconcile has things that are built in for you. It's got hooks that you can kind of take advantage of, so you can implement a validation. You can implement the defaulting. You can enable this kind of initialization phase for your object if things need to be set up, and so that ties into this status patching logic, which gets deferred. And then there's a deep copy, so it allows you to it saves this clone. This is going to be just renamed, but it's basically the older version of what was fired in the reconcile loop before we start changing the instance. And so then because of the way that the reconcile is put together, you're intended to not be modifying this code at all. Similar to how we have in the declarative pattern, you can just wrap that reconcile. You can just implement the interface for, where is that? I'm kind of forgetting how to navigate this code, even though I was just talking about it yesterday. Sorry, I'm blanking. But yeah, there's an interface where you can, have the validation and defaulting hook. You can, have the update status method, and wow, I have not woken up today yet. And yeah, you can implement on this controller object right here. You can set if the cleanup strategy, so you can enable, if you want finalizers on your object and that kind of thing. And then it does the timestamp comparison and all of that stuff that you need to kind of know about Kubernetes machinery in order to implement finalizers properly. So now you can just have the cleanup hook. You just implement your own cleanup in this handler, and then you don't have to actually know how to get all of this lifecycle correct. And that's really cool because the controller is tested thoroughly. So all of these lifecycle methods are usually something that you would need to test. You're like, okay, well, does the object initialize properly? Does it, finalize? Yeah, when I delete it, does it, are the things that are owned by it also deleted? You would have to write these tests if you were writing your own controller project. But now that there's this kind of different programming model being introduced, you can kind of inherit the tested behavior and stop worrying about whether or not you've implemented your lifecycle properly. One thing, yeah, I'm remembering what I was trying to say now. There is a operator class that actually implements a DAG. And so you can create operands. This is probably easier to look at in the example. So there's just a game controller example here. And in the game package, there's, you implement this operand interface, and you can just make one of these, put in all of the things that you need to actually interact with Kubernetes to create child objects and things like that. If you want to have a copy of the instance, you can update it, change the status and things like that, and then the status update gets deferred. And these operands can be formed inside of a DAG. You know, so then you can put a DAG together when you make your actual controller. This was, yeah, just when the controller is operated, it just ensures that it just runs the ensure method, and then the ensure method creates a config map that's owned, you know, by the thing. So, like, it's cool. Go check it out. The reason that this is pertinent is because if we're going to be encouraging people to be building add-ons, I think that Sunny's really identified lack of something like an express, you know, that makes common things that need to be done for all HTTP server type projects when you're building an application, things like authentication and like request form injection detection, and safety tokens, and all that kind of stuff. You know, there's this whole other class of problems that you get regarding lifecycle and machinery inside of Kubernetes that are just beyond generating types and setting up watches. And so I think that there's space, and if we know of other projects that are trying to make it safer and easier to build an operator or a controller that functions properly, then certainly, you know, we should talk about those. But I'm not aware of other work that is trying to make this safer at this abstraction level with using KubeBuilder and controller runtime and the kinds of things. There are additional packages in here that have some overlap and also some shared code with KubeBuilder declarative pattern as well. Struggling to click around. So there's this declarative directory that has like customized loader. These two are kind of overlapping, independent from what we did with our string maps inside of KubeBuilder declarative pattern. It's just a different approach that's using the in-memory file system and KYAML libraries. This transform thing is kind of related to that, but these things are actually used inside of the example controller, and then the applier is from KubeBuilder declarative pattern libraries. So take a look around some of this code. I think there's some useful bits. I haven't read much of Rancher's Wrangler, but I don't know if there's any of this kind of structure. Yeah, actually having a pre-computed reconcile that lets you opt into things like an initialization phase, like deferred status updates that are done properly, and having a DAG that can do requeues and things like that is not something that I've seen somewhere else. And this stuff is very formational, but we could probably get Sunny to come and do a walkthrough or something if people are more interested. And yeah, that's basically all that. Do people have like questions or comments? I know I just kind of ranted in time about this.
I mean, I think it looks great, and I think that this type of thing has sort of been missing for a long time in the ecosystem of tooling. So I'm really glad to see this sort of materialize.
Yeah, I kept getting more and more excited as Sunny talked about getting serious about doing this. And then like, as I've seen it materialize, like I'm a little bit in disbelief because I've spent so much of development time just suffering, writing controllers and not understanding when I've introduced a bug. And I think like I could definitely see myself using this and forgetting about common things that I've had to previously be concerned with. Cool. Well, I know that Nick.
Sorry.
Yeah. What's up, Evan?
Sorry. Before we move topics, I know this is sort of the thing that I know the operator SDK team has been thinking about and is eventually planning to work on. It's also something that they had considered working on a while ago, but ended up way more focusing on sort of the scaffolding aspects of writing operators and conventions there. So, I mean, I don't know if that's something that, you know, Sunny would be interested in, but I know there's interest in this type of thing from the operator framework. So if there's interest in collaborating there.
And there's certainly precedent
let
as
me know.
well in operator framework with things that are much higher level than this, right? Like this is, we kind of have a few patterns and then like a safe DAG and a couple of lifecycle hooks. But in operator framework, I know that they have maybe something similar, but it like ties in with Ansible, you know, where you can kind of plug in your own Ansible stuff and it gets run by the operator. So that's not Go. It's not just trying to make, you know, the most basic thing you could do simpler, but it is similar in concept. And I know that, you know, they have like the ability to kind of decorate a Helm chart with extra logic. So that's pretty cool. Yeah, I should mention that. Who do you think would be, what's the best avenue, you know, for Sunny to get in touch with the right folks? I have never been to an operator framework meeting per se.
So SDK has weekly meetings that they do on the CNCF calendar, and there's the Kubernetes operator SDK Slack channel as well, which is a good place. But all failing, if you just reach out to me, I can make sure we get in touch with the right people if none of those things work out.
Cool. All right, I will mention that to Sunny. Operator SDK folks. Thanks. Yeah, that's really good.
This might be getting too into the weeds with the specific like implementation of things, but was the DAG there? That was specifically for sort of triggering requeues of different objects that need to be aware of changes to other objects. Is that correct?
The DAG is so that you can implement your reconcile. So typically when you're doing a reconcile, you're like, hey, I want to make sure that this thing is done before this dependent thing next needs to get finished. The cool thing about doing that in a DAG is there is a class of bug in reconcile logic where if your reconcile runs without error, it's awesome. But if there are error conditions that the structure of your code doesn't create proper lifecycle, then it can be really difficult to reason about how that bug gets introduced and test against it and ensure that those things are not there. So if you change the programming model of how you do a reconcile, then you can pick an execution strategy and you can write tests to make sure that those execution strategies pass. So like if there's a common, it's a pretty early known pattern. They use it inside of etcd operator, where anytime they actually make an update to the object and the related things that you're keeping in sync, which for etcd there's a lot, then what they do is they requeue, because they are trying to run through their DAG from the top every single time they modify the system. And it's just a programming convention that they have within the functions that make up their reconcile. But if you actually kind of allow people to do that without having to think about it, because that's just the way that it works, then enabling that behavior, like if you want a quick reconcile, you can turn on a flag for it, you know, but then when you're developing, you can ensure that everything is functioning properly and inject failure and all kinds of stuff in between dependencies. So it really like cool potential to make sure that your reconcile is very robust and is not going to like fail on you.
Okay, I'll have to give this a deeper read. I must have misinterpreted what you were saying earlier.
The cross object thing was just about it relates to how to use the DAG and the framework to do that composite pattern where you have a child object or multiple child objects. And that the DAG is useful for that, right? But that's part of the reconcile.
Yeah, like I said, I'll have to read it to
It's
be able
inside
to have
of
the
the
conversation.
operator package. So there's the controller package, and then there's an operator package. And yeah, the DAG is inside the operator part.
Thank you.
Yeah. Sweet. Well, Nick, feel free to take the floor. I think we've talked enough about experimental programming improvements. So
Yeah.
I'm excited to hear what you want to talk about here.
Yeah, I mean, it's funny that you guys are mentioning this because I remember Evan and I went through this whole thing where we were talking about like hierarchical state machines and stuff way back.
Yeah.
And it didn't turn out too great, but this seems pretty promising. So I digress. Basically, at the beginning of December, I had signed on here to kind of implement the bundle spec in that KEP for manifests. And for those who don't remember, it's just basically a way to store manifests and metadata about an add-on in a container image. And one of the primary questions that I had as I was going through this is where to document the usage and the generation of these things, because I've seen that there are quite a few other remote sources like Git and I think HTTP that aren't documented today within the cluster add-ons repository. So do we have a precedent for that, or should we set the precedent with this and sort of backfill the docs for the existing stuff?
I think that you would certainly be doing the most formal work for what these sources should look like. So where those docs should live, yeah, let's. Justin, do you have a strong opinion about this at all?
I do not. Are there a couple of other candidates that we think make sense, or?
Yeah, I mean, I would totally be cool to just start putting the docs into the repo, and then, I mean, I'm not sure about hosting, if we would like those to be like web accessible outside of GitHub. Certainly this, something like a spec, you know, is very appropriate inside of a markdown file inside the repo.
Oh yeah, I totally agree. It's just like the organization of where to put it. There wasn't a lot to go with based on what exists today. So yeah. I just wanted to see if people had a preference.
I think that this is one of the first things that we've done that's more of a spec and less of like an experimental project. I think we've talked with plenty of folks and gone through the KEP process as well, and this is like something that everyone agrees, like we want to kind of get a good standard on. So yeah, getting some central documentation in an official place inside of under the cluster add-ons control would be appropriate.
Yeah. Okay, because I know a lot of it is actually
yeah,
within the repository.
When I did that other add-ons custom resource, you know, like we made a library, and there was like, you know, the API documentation was kind of the thing. And then Kubler declarative pattern has some like API, you know, conventions, and kind of the code is kind of that documentation. So pretty minimal in terms of specification, right? That's just where those things live. And how the Git and the HTTP stuff was supposed to work, you know, was really quite experimental. But the bundle stuff can go into I don't know, should we just have a docs folder? Should we have a bundle folder inside of cluster add-on?
The critical thing here for me is that like the thing that actually implements the ability to use both the local file system, Git, HTTP, all of that lives in the kubebuilder declarative pattern, of which has its own, you know, I think it was like the initial README, it looks like, kind of walks through how to use it. So should it live there or should it live in the cluster add-ons repository? Should it be at the root? If you want to brainstorm
that
this,
should actually behave, I think we should put a spec inside of the root of the, or inside of, yeah, like a folder related to that thing inside the cluster add-ons repo.
Yeah, I was gonna say I agree with that. I feel like there is an implementation in kubebuilder declarative pattern, but there is no spec document for it currently. It sounds like there should be one for what we've implemented in kubebuilder declarative pattern, and then that same spec could be implemented in other tooling. And so I think that like you're going backwards, as it were, or I mean, you're going the right way around. But like, so from that sense, like put the spec docs into cluster add-ons, and then if you want to do an implementation in kubebuilder declarative pattern, that'd be great. But there can also be other implementations. So
yeah, I mean, I'm almost positive that if there is a bundle spec, you know, that is related to a KEP about how to get manifests out of an image, at some point we're going to implement that in the new Flux controllers. So yeah, that would be definitely good. And then other projects like Tecton, you know, would probably be very interested in, you know, being able to interface with that from a CI perspective, you know, and that's not even a CNCF project, so they probably want some place for a central spec. So
okay, so that sounds super reasonable. I can sort of play with it and throw stuff at the wall and see what sticks. Maybe have something out at least before the next one of these meetings. So that's all I have to say about this particular topic. I think I have two more here.
Yeah, I think maybe my other reaction would be, like we've been mentioning, that there are some things inside of kubebuilder declarative pattern. So I'm sure like as you want to work on the bundle stuff, in particular for OCI manifests, like maybe you need to build tooling outside of kubebuilder declarative pattern, then we could vendor that in or import it. And then if we need to fix stuff so that the spec makes more sense, you know, we could probably change the way that kubebuilder declarative pattern works. So just not use that as a sole authority. It's really experimental, some of the way that those sources are functioning right now.
So you're already talking about the second point that I put down here.
Oh,
just so I'm clear.
Okay.
Did you or?
No, I wasn't reading that.
Okay.
I was just
That was
kind of
natural.
ad-libbing. Cool.
Yeah. Okay, cool. So I think our heads are at the same place. So the actual like simplest way to do this based on the way the spec exists, or I guess the declarative pattern channel spec exists, is to store the like directory structure in the root, and the spec for storing things in Docker v22 manifest, which is the bundle kept as it exists today, not OCI, keep in mind, is slightly different and is a set of sort of flat directories with some other icing on top. Now, the simplest and most straightforward thing to do, obviously, is to just put the original file system layout in the root of an image and then unpack that as a remote source with kubebuilder declarative add-on. So I didn't know which we wanted to kind of do like first, or did we want to treat this as an entirely separate spec, which constitutes a separate file system layout, which I think would get confusing.
I'm all for, you know, doing the simple thing with, like, if you would like to get the most minimal amount of changes. Like if you want to work directly on the Docker specific kind of image with the workarounds and trade-offs that were made inside of the KEP design to make that work with like the normal file system layers. Like I think that's a totally acceptable approach. We don't have to have like one spec necessarily. I think there's still evolving registry support for those OCI like different like meta tags.
That sounds reasonable. Thank you.
Yeah, there was kind of like multiple things going on. I think the other part that I heard you asking about there was how should the KubeBuilder declarative pattern stuff behave with regard to unpacking the sorry, I had to decline the call. With regard to unpacking the bundle, and I would say, you know, that behavior doesn't exist right now, so we might as well just make it behave in whatever the first spec looks like. And if we need a separate spec that like says, hey, this is how we imagine, you know, this could work in, you know, a perfect world where support for OCI is mature, that's something that we could work on for like a V2 kind of thing. But I imagine that would be down the road some, unless other people have a different view of container registries. I haven't like kept up with the Harbor project and where Quay is at with their public offerings and GitHub container registries, support for OCI blobs of stuff.
Yeah, the only thing that I wanted to avoid was to kind of give end users too many options and too many specs and too many things to worry about, because I know that gets really frustrating and hard to debug.
Yeah, it's like if I'm Flux or Tecton or Concourse CI and I'm trying to do cloud native artifacts, you know, it's like what do I implement?
Okay.
Yeah. So that's definitely a concern for sure.
All right.
Yeah, the other people feel free to chime in if you have opinions on how this stuff should work, because it's definitely, I mean, we kind of have to build the world here. It's great because, you know, with kind of the OLM like ecosystem, at least there is some prior art in how this stuff can function. So that's cool. Sweet. Well, Nick, props to you for taking this on. It's definitely a significant task, and whatever we can do to actually get in there and help. Like I'm sure some of the initial stuff will just be like ripping the spec apart, right, and actually trying to come up with something that makes sense.
Yeah.
But I feel like that a lot of that has been done with the KEP, you know, so any other technical bits and stuff, like, you know, we have people here to help with any technical implementation bits as well. You wanted to talk on this next bit about like what it means to like parameterize the manifests.
Yeah. So as I was like taking a closer look at a lot of what KubeBuilder declarative pattern was doing, it kind of strikes me that like the thing that you get with the file system is that method of keeping track of things next to the the binary of the add-on operator itself is that you're basically tying a set of versions of an operator to, a set of versions of an add-on to an operator, which seems like a completely necessary thing to do. And when you allow that, when you parameterize that and make it so you can swap it out at runtime, the add-ons that an operator is managing, it sort of removes the meaning, or like I can't really reason about, sorry, a little alarm. Can't really reason about how an operator is supposed to know whether this add-on image that it's pulling down and unpacking actually meets the criteria that it expects or that it knows about. So like, you know, I could, for example, I can have an etcd operator and I could give it Prometheus add-on, let's say, if that was a cluster extension, Prometheus add-on bundle images, right? So like the meaning is kind of lost there. Like it seems to me that there's, you know, a reason for a tight coupling between an operator and a set of add-ons versions, and being able to swap that out doesn't seem to make a lot of sense. Sorry if I was rambling. Brain is taking a while to turn on.
I think that there is potential for people to extend the fact that these things are modular. There's a couple of benefits. First, the manifests are useful on their own and people can extend upon them separately, right? So if I, you know, am working, say I just signed a contract with a vendor and I want to use their software, they give me an add-on operator. Their add-on operator uses a bundle. I can push their bundle to my internal registry. I know that it's signed by them, and I can see what's inside it. I can inspect, you know, in general, what they intend to install to my cluster, and then, you know, like I can decide to use their operator, and the operator doesn't have to bundle all of that in, but you could potentially continue using it with the newer bundle, right? So that helps with maintenance. You know, if you're just trying to ship manifest changes as the vendor, you know, or the, you know, the maintainer, then you can tell them, hey, can you just update the channel? You know, and the operator can still work with it. And if I, you know, find a bug and need to hotfix something, I don't have to build their operator. I don't have to modify their code. I can, you know, change the node selector, you know, which is something that the operator may have never, you know, had in mind. Right? There might not be any code related to, you know, templating a node selector or appending it. But I can go in there and I can fork their bundle, push it to my registry, sign it with my own keys, you know, and then make that operator use that bundle instead. So there's already this use case of like, here you see the benefit from the maintainer, you see the benefit of like the visibility. Now I can see the manifest inside. You see the benefit of hosting, right? So there isn't a mystery on like, how do I get this source? It's like I have a registry in my, you know, air-gapped environment that I can use. And then there's the ability for the user to potentially extend it because the abstraction is not leaked. You know, I don't have to modify the bin data of some, you know, binary, you know, some Go binary. So does that, now the question of like, how does the operator know that you're not giving it the wrong package, that probably has to do with the metadata portion of the spec. Because yeah, like in a bundle, you know, could be in any number of registries with any number of tags. So how do you actually talk about the metadata authoritatively? Like maybe the name of the image is not super related to what the name of the package that's actually bundled inside is, or maybe it is, that has to be specified. But the tag, is probably something that needs to be within a certain number of constraints related to the actual version of the thing. But the registry that it's hosted at, that could probably be anywhere. I don't know. I'm just guessing. That the metadata of how does that thing know that it's actually useful, or that it's what it's intended, is part of the spec.
Yes, and I mean, like, as so long as the metadata is sort of up to modify, because I can like create a separate bundle that says I can trust this, or this is said package. Short of like signing content and providing ways to sort of overlay new content on a bundle while keeping the different layers of it signed and secured. I think it's going to be really hard to ensure that an operator will be working with the bundles that you give it.
Or that the maintainer intends, I suppose. Is that what you're mentioning?
Yeah. So it's hard to determine whether the maintainer's intent is preserved through customization of the bundles that you're passing an operator. So I think that's like a core problem that I wanted to get people's opinions on.
If I may, we do have one mechanism which we know about, that actually Satoshi, I think, added, which is, we know that there will come a time when you want to add a new variable or like a placeholder, and you need a newer version of the operator to support that package. That is not a problem if it's all on the local image, right? Because they're distributed together, but it is a problem with Git or HTTPS distribution, and presumably with Docker registry distribution. And I believe the mechanism that was added by Satoshi is that a manifest can declare a minimum version of the operator. It is only it's fairly restricted. Like, it's only a semver version, so it doesn't protect against like cross packages, but it does at least address that issue. We could certainly extend it to prevent accidentally crossing the streams, right? So you could say expected operator key or expected operator ID must be like etcd manager and not Prometheus manager. It wouldn't be secure, it would just stop mistakes. That might be useful.
You also could go beyond that. I mean, if we agree that bundles, it's like every kind of additional metadata that we push onto folks who are authoring bundles, like the further we stray away from the current ecosystem, which is like where people have a bunch of manifests, being served from a Git repositories archive or something, or like server on some, hosted Git service. Right. So like a lot of people are just doing kubectl apply f, some manifest over there, and maybe they download it and modify it. So like the operator goes beyond that, and we're talking about packages. If we, enforce that packages, say what operator they should be used with, right? It's still usable in the apply f, but now there's this one extra step in authoring that thing to be used with an operator. And the operator could say, fire warnings, or, it could have a pre-flight check, that says, I must have this annotation or I'm not going to use your bundle, and then that pre-flight check could be ignored. That kind of thing. But the good thing, right, is maintainers, should as long as that's not too much of a pain for them to maintain, that annotation that expects the operator from the package that matches it, then that's good. And then users, always have control over what bundle, they want to be using in the operator use case, right? So that could, be an example where, whoever has permission to control the bundle can fork it, if they want to make it not fire a warning. But that would prevent mistakes.
Yeah, I mean, like the opposite angle would be to package operators and the set of add-ons that they install in these bundles, and not the add-ons directly, or package both and just like embed the bundle to pull, even though that wouldn't, be the most efficient thing, because we could always do transformations on the content in other ways.
Yeah, I think the way it's a little funky to say like use the operator image as a bundle, right? For what you mentioned, I don't think that this is good because Go binaries are massive in comparison to Kubernetes YAML. So you're going to have to pull that bundle image once, to actually execute the operator on the node with whatever CRI you're using, and then twice with the, in-memory library. And that's just really silly. If you look at the way that KubeBuilder declarative pattern works right now, this is basically already an implementation that does package the add-on inside of the image that executes. So if maintainers are looking for that kind of one image solution, the operator is coupled with the add-on. If you're trying to get the benefits of having the bundle and the operator decoupled, I don't think you're going to get away from the operator binary and the package intended for that operator from being packaged as two separate images, or like a bundle and a container image. That's kind of my initial instinct and on it.
Totally.
Yeah. Mm-hmm.
I totally get it. I don't know that, like, there's enough space on the internet to store as many images as you want, right? So like, I could see a world where, like, if you want to have just apply your add-ons, you have an image that just has the add-on and you apply directly and there's no operator. But if you had, an operator that consumes add-ons, you could bundle it as you do today with the file system format, and have an image that you apply there. But yeah, I think we should talk about this more in the chat later, if that's cool.
Okay. Yeah. Mm-hmm. Yeah. Let's move some of the discussion about operators using bundles and packaging and safety and the benefits and caveats into the cluster add-ons Slack channel. Sweet. Cool. Overall, I don't really feel like there's too many gotchas. So feeling confident and super happy that you're driving this. Thanks, Nick. Great. Evan, you had one more thing that you wanted to share. You're still hanging out with us.
Yeah, I'm here. I thought this would just be for fun, but I think it's actually surprisingly relevant to the discussion today. So let me share my screen really quick. Oh, I can't share my screen. Well, if you click on the link, this is sort of like a side project. Oh, I can?
Yeah, I just fixed it. My bad.
Oh, here we go. This is just a little side project I was playing with a couple months ago. But I don't know if you've seen Q, the configure, unify, execute language. But I think it has a lot of promise, and it's making some interesting strides in the configuration space. And one of the things that is kind of a personal pet peeve of mine about writing Kubernetes manifests is that there's a huge set of problems where you can't just declare stuff. You have to wait and do things in some imperative order, because you have to first apply a manifest, wait for some controller to do some work on it, get out some value you need for another manifest, and apply it somewhere else. So this is just a little project that tries to solve some of that by using Q. So this is my toy example is if you have a role with a generate name and you have a role binding and you want that role binding to reference the role that you generated, and with just kubectl, that's like 4 or 5 steps, right? Because you create the role, edit the role binding, reference the role, apply it. But then if you're using Q, and I won't go into too many details about Q because it's kind of a big topic, I can create the role and the role binding and have the role binding reference the name of the role. And what kubectl does is it continuously reconciles these resources that you've defined in Q with the state of the cluster. So what it'll do first is create the role, because that's sort of like a complete definition. It doesn't need it, it's not missing any data. And then once it's created, it'll sync the state from the cluster back and unify the values with what's here using just normal Q machinery. And then the role binding, this value will finally be able to be hydrated by Q. And then this value will be complete, and then it'll automatically create that as well. So you see that when you just apply the toy example, you get the role binding can't be applied, then the role is created, and then the role binding is created. And I've sort of been playing with these ideas and found them to be pretty useful, just for like local testing, provisioning things locally against like a kind cluster and things like that, where I want to be able to spin things up quickly in parallel and not have them conflict. Or I think another use case I found was wanting to be able to direct internal traffic out through an ingress and back into the cluster. And so the only way, the simplest way to do that was just to have some kubectl stuff that referenced whatever the final cluster IP that was assigned to the ingress was. So I could direct traffic just to the IP, and then it'll come through the ingress controller for some testing I was doing. So I don't know, I think it's pretty relevant to a lot of the stuff we talk about here. It's kind of like maybe an extension of the kubebuilder declarative pattern to a degree. And this is written to eventually be a thing you can run as a controller. I mean, you could run it as a controller right now. I just kind of pitched it as a CLI tool or a kubectl plugin. But it's all, you could just spin it up in a pod and it would do everything there. My big reservations are that Q itself is still in flux. So I don't think this is anything anyone should really use. There's still weird edge cases where you'll hit a panic in Q or something like that. And so you don't really want to be using it in a cluster where you can't always control all the inputs. But I think once Q is stable, this could be a really interesting approach for some class of simple operators. And so, yeah, just wanted to share it. I think it was fun to work on, and maybe is
It looks super fun.
Group.
Yeah, you built an apply DAG that reflects off of the state of the API server. And
yes,
yeah, that's kind of the thing, is just like if that IP were ever to change, right, then you would need to run the apply again, right? And so that's when it turns into a controller. So
yeah,
very cool.
The CLI tool has like a watch flag, and that puts it kind of in like the controller mode. So if you
it has an apply
watch.
watch.
Yeah, it's kind of weird, but
that's so cool. Nice. Okay, cool. Thanks for sharing that. Yeah, you could totally see how you could just put that in a controller. Maybe you could have I don't know, Q in a bundle.
Yeah, exactly. Or bundle the Q files in with just a runnable image and run embed kubectl in that as well.
Yeah.
Yeah.
Ideally, all
think,
that
like,
stuff.
I don't know if this
yeah.
is.
ideally people have choice, right, on how they factor their stuff. You know, maybe the maintainers ship with a Git repo, but then you want to put your queue stuff into a bundle image in your locally hosted registry and configure the operator to look at it instead. You know,
Yeah, definitely.
That'd be a really cool world to be in. Nice.
Yeah,
Thanks for sharing
long term,
that.
one of the interesting things about Q is that you would have the ability to write manifests and then ensure that their configuration is backwards compatible. That's one of the benefits of using Q, is that you can take two disparate configurations and then answer the question, is this new spec and new schema backwards compatible with this old schema? Which is sort of like an update problem we have for configuration of operators or controllers in general.
Yeah.
How do we know that an operator author providing an API or a controller providing an API has actually followed the conventions so that the existing config continues to work with the next version during some transition period?
Mm-hmm.
But
well,
for that to work,
the
that
queue
requires
as well
very
allows you to
consistent.
do parameterization, gets you all of that other richness where you can build a formal interface and indirect from the operator, so that doesn't have to know as many things about the package. So that's like, yeah, it's huge. And then if you can provide stability to that same indirection kind of API that you built between the two, then that's really cool. Then that gets into what Justin and Nick were bringing up about how does the operator know that it can trust, you know, that inflating this package is an intended behavior. Yeah. Interesting. Cool. All right. Well, we're running slightly over time. I guess we did start a little behind, but we should let people get to their next thing or make their English breakfast or whatever. So awesome to hang out with all of you. You're all brilliant folks. Great to be starting a new year. Thanks so much for everything that we did last year, and let's have another good one. Yeah. See you in 2 weeks.
Thanks a lot, everyone.
Thank you. Bye.
See you.